So example number 1, we're going to find the deflection at the midspan. So since we're talking about midspan, means to say that we're going to get the deflection at the middle of the span. Since we have a simply supported beam and the span is 5 meters, therefore the midspan is at 2.5. So we have now the idea that we're gonna find the deflection when x is equal to 2.5 meters, because later on our function will be expressed in x. So first things first, let us solve for the reaction. Anyway, we won't be getting the horizontal value of the reaction at R1, and because it has nothing to do with the deflection. Okay, so we're gonna solve for the reaction, and by solving, it's going to be summation of moment about R2 equal to 0 para ma-solve ang R1. So R1 times 5 minus 35 times 3 equal to 0. So we'll have R1 equal to 35 times 3, 105 divided by 5, that's divided by 5, this is 21. So this is our first procedure. So it's really important to determine the reaction first. And of course, although we know already that we won't be using R2 because later on we will be cutting through that, so might as well get the reaction na lang po. So summation of forces vertical equal to 0, you will have R1 plus R2 then equal to 35. Since R1 is already known, that is 21, we can now get R2, and that is 35 minus 21. So R2 is basically 14. So ngayon dili dito mag-need sa R2 later on. So ato sang i-describe ang deflection sa ato ang beam whenever the load is applied. Somehow, this is the kind of deflection. Ako lang i-exaggerate. And then, this is the kind of, ako lang i-broken line. So, broken line lang na ako. And then, where is the midspan? It's 1/2 of 5. So, maybe na diri dapita diri nga portion. So from this position padung dira, we call that the displacement at the midspan. No? So from this position of the beam padung diri, that is the distance of our displacement. So mo na tong pangitaon. First is we're going to cut the beam and consider the left section. And by cutting, let's redraw the figure. So here, and we have R1 here. R1 is 21. And then 2 meters. Kay naa ang 35. And here, kaning nga distance diri, this is no longer 30 meters. Nga naman, because at this particular point of cutting here, diri dapita, naatay moment diha. So, moment na atong point of cutting, let us express the distance from this point here padong dire, padong sa rightmost side, and this is the function of Rx. And then here, this is the function of not 3 meters anymore, but rather the subtraction of x and 2, no? So it's going to be x minus 2. There. So we're now ready to formulate the moment equation. So moment equation, how to formulate moment equation. So it's going to be EI of the moment is equal to the summation of moment, clockwise positive, counterclockwise negative. So let's start with R1. So EI moment, by the way, EI is the flexural rigidity. So it measures the rigidness of the material with respect to its moment of inertia. So magkadako ang suction, magkadako ang iyang rigidity. So it is resistance to flexure or bending. So that's why it's called flexural rigidity. Let's start with R1 or 21. And that's going to rotate about point of cutting here with the clockwise direction. So I'll have 21 times x. No, moment arm of 21 is x. Then let's proceed with 35. 35 is counterclockwise about point of cutting. So minus 35 times, so it's going to be x minus 2. X minus 2. That's it. This is our moment equation. So proceed ta, and we're going to integrate the moment equation. So it's going to give us EI of theta, and that is 21 integral of 21x, that's 21x squared over 2. Then minus this one, 35 times x minus 2. So do not distribute, dili nimo siya i-distribute ha. Wrong na siya. Ayog i-distribute because that is not a binomial. That is not a function of binomial, but rather it is a function of its moment arm. So gi x minus 2 na siya because we try to kanang differentiate or no, integrate the particle from x portion equal to 0 to x equal to 5 because the length of our beam is 5 meters. So whole term na siya or whole function. So murag na hog rapod na siya nga as x. So that's 35, then x minus 2, then 1 man na siya diha, so 1 plus 1, so it's going to be 2, then divided by 2, and then the plus c1, the first arbitrary constant. So this is your general slope equation, not the solution yet. So later on, we're going to get the solution, meaning matangtang na siyang C1. So that's how we are going to evaluate. Next, let us proceed, integrate further. So ato na siyang integrate, kana siya. So it's going to give us the EI of deflection, and that is equal to, if you do not resolve 21 over 2, pwede ra sad nimo siyang i-21 over 2 diretso, no? So it's like 21 x 2 man na siya, 3 cube, and then since naman kay over 2 daan, so over 2 times 3, no? So same sa atong gibuhat sa integral sa una. Then minus 35 times x minus 2 cube na diha over, so 2 divided by, 2 times 3, then plus c1x, then plus c2. So pwede na nato siyang i-resolve. Deflection, that is 3.5 x cubed minus this is 6, 35 divided by 6. So that's 35 divided by 6 lang. So 35 divided by 6. And this is x minus 2 cubed. Then plus c1x, then plus c2. So this is your general deflection equation. There. But we're not done because we're going to evaluate. So let us evaluate C1 and C2. How? Look at the supports. Ang supports kay naa diri dapita. So the hinge is at x equal to 0. No? Nganong x equal to 0 man na? Okay, remember that we established this boundary line as a function of x padung sa right side. So iyang gi-describe ang function sa x, meaning x starts at 0 and x ends at 5. No? So diri man ang atong sinugdanan, diri po ang atong ending. Kay mo man na ang length sa ato ang beam. So I hope na clarify na siya diha dapita. So ato siyang i-cancel out. So here, this is x equal to 0. No? So I'll label this one as our letter A. And then this is our letter B. Okay? So let's proceed here. At point A, there is a hinge, di ba? Ganina. No? At point A, there is a hinge. Kana siya. So therefore, naman sa point A, x is equal to 0. Okay, naman siya sa pinaka-left side. So, since naman tayo hinge, ang value sa atong deflection is equal to 0. Sakto ba? Basta hinge. And then, ang atong slope, dili siya 0. Pasabot, we are going to use, hindi ba maklaro? We're gonna use this one. Use general deflection equation with this value. So what is our general deflection equation? So mo ni atong general deflection equation. Sakto ba? Mo ba na atong general deflection equation? Yes. No. So mo na atong kopyahon. So here, let's copy that and let's paste that one here. Okay, so that is our equation. What we're going to do is substitute the values. So we're gonna substitute the deflection here, no? Deflection equal to 0. And then our x equal to 0. So that's 0. Then kana 0. Yeah, this one here is 0. Pagkahuman, ang nahabilin, if ato siyang isuwat balik, this is negative 35 over 6 times negative 2 cube. Ya, kay negative man ang sulod ana, therefore, automatic 0 na siya. So, unsa diya ang atong equation? So, may tabo, siya na lang yung nahabilin. So, what we're going to do now is rewrite everything from here, padung diri, 0 na siya tanan. So, therefore, C2 is 0. So, nanatay, adi lang na ko siya i-box. Kaya, that is not a final answer man. So, ato lang siyang i-highlight. This is the value of our C2. So, later on, we're going to substitute this C2 sa diha para mahimo na siyang solution. No? So, let us proceed. We're done with hinge. And then, ang next natong tan-awon is the next support. Ang next support kay nasa point B. So, naman to sa point B, therefore, x is equal to pila man. From left, diri dapita, from left here, padung dito, pila may distance sa atong x. Diba? The distance of our x is the length of the beam, which is 5 meters. So therefore, At point B, no, ato lang i-rewrite. At point B, there is a roller. And that is at x equal to 5 meters. Kung not a roller, then it will give us a value of deflection equal to 0. Pero ang slope, dili siya 0. Therefore, ang magamit ra nato is only this, no? Which is use general deflection equation. So, mo na itong gamiton. So, atong i-paste balik si general deflection equation. Here. General deflection, and we're going to copy that and paste here. This is the general deflection equation, and then we're going to substitute the deflection. So ato i-substitute si deflection equal to 0. Pagkauman, this time x is equal to 5, not 0. So ang buhaton na to, ato lang siyang i-rewrite para dili ta maglipog. So this is EI times 0 equal to 3.5 times x now is 5 cubed minus 35 over 6 times 5 minus 2 cubed, then plus C1 times 5, then the C2 value is already 0. Na naman tayo value sa C2. Okay, so resolving this one, it will give us the C1 value. So C1, atong i-compute ang value sa C1. So that's 0 equal to, so I have here my calculator for a while. That's 3.5 times 5 cubed minus 35 over 6 times 3 cubed plus C1 5 times 5. No? So our C1 is negative 56. So right now, nanatay value sa atong C1 and C2. So ang buhaton nato is we're going to rewrite the whole thing. Diba? So kani siya, ato ni siyang i-rewrite. So here, ito rin nato siya i-place. And then alam ko i-delete. So this time, we're gonna substitute C1 equal to negative 56. So atong i-substitute ang negative 56. So that's negative 56. So this is our equation. So this is general slope solution. Nganong solution naman siya? Because at any point sa beam, masolve na nato ang deflection. Ang slope. Tungod sa natangtang naman si arbitrary constant. No? So, ang atong function na lang is about x naman. So, pwede na ka makasubstitute of any value sa atong x. So, that's it. The general slope solution. How about for the general deflection solution? So, ang buhatan na to kay copy this. And then, let's paste it here. Okay, and then do not forget that we're going to substitute the C1. No? So the C1 is negative 56. So it's negative 56x. And then C2 is 0. Pwede rasad nga dili na lang nato na siya isuwat. Okay? And then, this is now our general slope, general deflection solution. That at any point sa ato ang beam, we can now get the deflection value. So according sa problem, that we're going to get the deflection at 2.5 meters. So ang buhaton nato kay we're going to substitute x equal to 2.5 with this equation. So here for so muna to know, we are going to get the deflection at the midspan. So we will be using x, nasa na-erase man. We will be using x equal to 2.5. And since namatay duha ka equation, remember deflection atong gipangita. So of course, we will be using this equation. Kani. No, kay gipangita is deflection man. Kana, deflection. So, dili ta magpataka sa equation kay masayop ta. No? Again, this is intended for the slope and this one is intended for the deflection. So, I hope na clarify na siya. And with that, since mag-solve naman ta deflection, we are going to copy this and rewrite that one here. Okay, I don't have space anymore. Okay, and then of course, that we're going to substitute x equal to 2.5 meters since gipangita nato ang deflection at 2.5 meters. Okay, so buhaton is substitute EI deflection amoy gipangita equal to 3.5 times 2.5 cube, then minus 35 over 6 times 2.5 minus 2 cube, then minus 56 x is 2.5. I almost forgot. Okay, so let's just resolve or simplify lang. This is 3.5 times 2.5 cube. This is 54.6875 minus 35 over 6 times 2.5 minus 2 is 0.5. It's still positive, so dili na to siya ma-neglect. So 0.5 cube, the value is 35 over 48. So it's really important not to write the decimal equivalent kay magka layo ang imuhang value sa real value. So 56 times 2.5, 140. So this is 140. And simplifying further, so it's going to be 54.6875 minus 35 over 48 plus 140. Minus 140 rather. Minus 140. The answer is 86 negative. So this is EI deflection, and that is negative 86.042 kilonewtons cubic meter. So nganong inani ang units kilonewtons cubic meter? Kay of course, this term here, ato lang iklaro. This term here is the force, and this term here is the distance, and this is the power cube. So what is the unit of our force? Force nato unit is kilonewtons. Unit of our distance, that's meters, and it is in cube. That's why mo na iyang unit. And nganong negative na siya? Nganong negative? Because the position of the beam. So this is the position of the beam, and then naatay reaction dire R1 and R2. Pagkahuman, our deflection is in this manner, diba? So, ang nahitabo kay there is a deflection downward. No? And then of course, ato maning giset as the Cartesian plane. The y and this one here is the x. So, kani positive x, kani negative x, kani positive y, kani negative y. Or positive deflection and negative deflection. So, negative man siya because ni conform siya nga downward ang deflection sa atong beam. I hope na clarify na siya. And let us have this one as our final answer. So this is our final answer. So this ends our first example. Let's proceed to our second one.